All right, we're back. This is video 2 on t-test, and you'll notice that we are still on the slide talking about the logic behind a paired samples t-test. Okay, we're using one sample of different scores to test whether there are differences in two treatment conditions in the population. Okay, the mean for the population of different scores. Okay, so the t equals the sample mean minus the population mean divided by the estimated standard error. And it looks like this. Okay, t equals the mean, the sample mean minus the population mean divided by the estimated standard error. Okay, we get this population mean from the null hypothesis, we get this sample mean from the sample data, and the formula to get the sample, the estimated standard error is the square root of s squared divided by n. Okay, and if you put them all together, the sum of square root equals the sum of squares divided by n minus 1. Okay, and we're going to use, don't panic, we're going to use SPSS to work these problems out. So going to the next slide, this is the formula. T equals the sample statistic minus the population parameter divided by the estimated standard error. Here's the calculations to get the difference scores. You remember, so person A, B, C, and D, before the medication, this is their score. This is the X2 scores after the medication. This is the difference. Okay, so the sum of the differences equals 64. The mean difference equals the sum of the differences divided by n, which is 64 divided by 4 equals 16. Easy stuff, right? This is the hypotheses for paired samples t-tests. Okay, remember the null hypothesis is going to be students' proficiency in stats will be the same at the end of this course as it was before the course. What is the alternative hypothesis? Go ahead, raise your hand. All right, go ahead and tell me. That's right. And the second hypothesis is the null hypothesis is that asthma symptoms remain the same after an episode of anxiety. Tell me what you think the alternative hypothesis is. Independent samples t-test is the one that we will focus on. It is the most commonly used. All right, and this is what it is about. In independent samples t-test, the data is drawn from completely separate groups. So it's not within subjects, it's between subjects, okay? This type of research is referred to as between subjects. In independent samples t-test, we are looking to test whether the means significantly differ between two groups. That is, the mean differences between two populations. Example, compare the annual salary of UNH professors versus Quinnipiac University professors. Other possible groups to compare are men and women, students taught by method A and students taught by method B, etc. So they're different groups of people, and we're comparing the means of some score in different groups. And this is the logic behind an independent samples t-test. All right, we're using two sample means to assess two population means. So the t equals the sample mean difference minus the population mean difference divided by the estimated standard error. And where do we get the, here's the two of these, the two sample mean differences. Here's the two population mean differences, and remember the big M, small mu, and this is where we get this from the sample data, we get this from the null hypothesis, and the amount of error expected when you use a sample mean is M1 minus M2 to represent a population mean difference. Okay, sorry about that. This is simply between sample means. Okay, is the t equals observed differences between sample means, and it's divided by the difference expected by chance. And these are the hypotheses for independent samples t-test. All right, the first is that there is no difference between the IQ of students who sit in the front row versus those students who sit in the back row. What's the alternative hypothesis? The second question is that there is no difference between the income of academics and that of Wall Street investment bankers. What is the alternative hypothesis? And chances are that's going to be the true one. Here's a comparison of formulae in single sample and independent measures according to Graviter and Wallnow. Okay, and you can take a look at that, because we're not going to be, I don't expect you to remember this. It's just here. You could stop the PowerPoint and take a look if you're really interested in this. We're going to move on because SPSS is going to do this work for you. Remember degrees of freedom? They're numbers that you choose freely, that you can choose freely. Okay, in chi-square, the degrees of freedom equals the number of rows minus 1 times the number of columns minus 1. With independent samples t-test, degrees of freedom is determined by both samples. Okay, so the degree of freedom for t-test equals the degree of freedom for the first sample plus the degree of freedom for the second sample. And there's the formula, and it is the total number of cases, including all groups, are k-groups. Okay, that's the name of what that parameter is. It's k-groups. And what do we do with a t-value? With t-values, we disregard the plus or minus sign. All right, just like with the chi-square values, you look in the t-distribution table to determine whether differences are statistically significant and whether the test is one-tailed or two-tailed. And you remember, one-tailed is that we are speculating that it's going to go in one direction under the one or the other tail of the curve, and two-tailed is we don't know. It could go under either way. So what does the plus or a negative sign mean? That's right, we get rid of them. And the advantages of repeated measures design over independent samples t-test. Okay, the number of subjects. Number one, repeated measures design typically require fewer subjects than an independent measures. All right, they use subjects more efficiently. Repeated measures design study changes over time. All right, so they're useful for a longitudinal analysis. And individual differences can influence scores in a study and affect the outcome of the hypothesis test. In a repeated measures design, individuals serve as their own controls, and that they eliminate problems that way. The disadvantage is that there's difficulty in attributing changes to the intervention alone. Treatment effects, the participation in the first treatment may affect the score in the second treatment. An example is that you get tired and bored and don't perform well in the second treatment, or you begin to deduce the reason for the study. And it requires data collected over time. Here are the postulates for paired sample mean test. Okay, number one, independence of observations. Scores within each group are obtained for different individuals. 2, population distribution of difference scores. The d-values must be normal. Okay, so that's got to be a normal curve. Non-normal distribution of the dependent variable will compromise the validity of the t-test in samples with less than 30, and with n greater than 30, this assumption can just be thrown out. You don't have to worry about it. Postulates for independent sample means test. Okay, one is that independence of groups is important. They have to be mutually exclusive. The dependent variable has to be normally distributed Okay, and it's less important with really large samples. And the homogeneity of variance between the groups is important. Remember that the variance is a measure of the spread around the mean. So homogeneity of variance refers to the idea that the spread around the mean has to be similar between the groups. And remember, this is important. Levene's test is the one test that needs to be non-significant. We do not want Levene's test to be significant. Okay, so we want it to be greater than 0.05. The null hypothesis, p greater than 0.05, stipulates that there are no differences in the variances between the groups, which is the condition that we want. Fmax equals the largest sample variance divided by the smallest sample variance. All right, and we look in the table in the back of the book, the Fmax value table for a given number of samples. 2 samples, an independent samples t-test, and a given number of degrees of freedom, n-1 for each sample, and you can tell if your Fmax value is in the critical region. Okay, if the Xmax is less than the critical region, then the homogeneity of variance assumption has not been violated. And of course, where are we going to do this? We're going to do this in SPSS, so we're going to know immediately if the homogeneity of variance assumption has been violated or not, because SPSS is going to look in the Fmax table in its little SPSS brain. So this is how to report results of a t-test. There's a significant difference between the average number of pints consumed by men and women. T equals 4, that's the T number we got. P is less than 0.05, that's not Levene's, now that's P, and the degree of freedom equals 12. We say on average, men are able to drink more pints of beer, M equals 12, standard deviation equals 2, than women, M equals 4, standard deviation equals 1. On average, students perform better on proficiency test after the course, M85, standard deviation 5, than before, M equals 70, standard deviation equals 5. This difference is statistically significant. T equals 4, P is less than 0.05. Again, it's not Levene's, okay? And we want Levene's to be greater than 0.05, and the degree of freedom equals 12. Next week, we talk about the F-test, and remember that the t-test for comparisons between is for comparisons between 2 groups. The F-test is for comparisons between more than 2 groups. And in summary for this week, when you want to test whether the mean of a single variable differs from a specified constant, you use a one-sample t-test. When you want to assess whether the means between 2 groups are significantly different, you use the independent samples t-test. And when individuals are measured more than once on the same dependent variable, and you want to test whether the differences are significant, you use a paired sample t-test. And now we will pop over and I'll do another video. Look at the handout that I put in the discussion thread, and I'll do an SPSS demonstration on how to do t-test, and that will of course be up on the discussion thread. Thanks, and I hope you enjoyed learning about t-tests. They're really handy, and if you have questions, please let me know.